My name's Andrew Bennett. I'm a general advisor with the Kootenay and Boundary Farm Advisors. I'm joined this evening by my colleague Sarah Hirschfeld, who's the coordinator of the program. We are a local agricultural extension. We offer free services to farmers in southeast BC, ranging roughly from the border with the Okanagan out to the border with Alberta and up as far as north as Revelstoke, Golden, and even a bit beyond. If you have any issues on your farm, please feel free to contact us. That's the short message. We work to put you in contact with expertise, resources, information, and work with you on whatever the issue is. We're free, do use us. We also do a lot of workshops. We're coming into, the spring is fast approaching and we'll soon have a lot of field days. Please let us know if there's a field day that interests you. Call us anytime about that, send us an email. And right now we're just in the middle of our winter webinar series, and tonight it's water storage. And you get to have the dubious pleasure of listening to me drone on for 45 minutes to an hour here about all things water storage. Overarching all of this is the enormous climate and landscape change that we have seen and will continue to see. And through it all, one of my strong beliefs, I believe founded in fact, is that our resilience as farmers, as a society, as a province, as a nation, as a world, is really rooted in how we manage our soil and our water. And that's what a lot of this evening's presentation is all about, is soil and water management, how we can do a better job with them, and how it's going to make our farms stronger and our society stronger. We're going to start off looking at funding opportunities. How am I going to get some money to fund my dugout, that kind of thing. Resources that are out there, there's a pile of them. A lot of whole farm planning. When we're talking about water, we really have to think whole farm. That's going to move us through questions of soil, hydrology, landscape considerations. And we also have to think about why we need this water. So farm water needs. I'm going to really focus on irrigation. Livestock, of course, need water. We need water for a lot of other things, wildfire protection. I'm not likely to cover all the needs. So this is, again, please do bring it up at the end or during the chat, and we'll talk about it. Dams and dugouts. I'll give you the short answer here. You really probably don't want to get into dams. So we're really going to focus on dugouts. Dams bring in a lot of issues, and we'll briefly go over those before moving to a dugout example and going through a bunch of liners, because not very few of us are blessed with the clay that you need in the soil to actually retain a pond without it leaking out. We'll talk about how to turn your pond into something more ecological, which will benefit you in terms of water quality as well as personal enjoyment. And then we'll have a discussion about it all. As seen on YouTube, one is a 4-part webinar series that I did with Bruce Naka, who is an excellent irrigation designer out of the Okanagan, who I've had the pleasure of working with a lot. He's got 40 years of experience in irrigation design, and he does a 4-part webinar. I did the slides, he does the talking on right amount, right time, right place. If one of the crucial things to think about with water storage, it's just like money. It's a lot easier to not spend it than it is to earn it. It's a lot easier to store less and use it more wisely. So crucial that we get our irrigation efficient. And there's a lot to that. From that webinar series, we turned that into a 12-part video series. So in 2022, I put out 4 to 8 minute long videos, 12 of them, working through your irrigation efficiency. I'll get back to other resources. I wanted to point those out because that's often, the most visual, easiest entry stuff. Funding, though. You will get the funding spiel in this little video on one way to get professional irrigation advice is through the Beneficial Management Practice Program. and there is these amounts of funding available for designs. Irrigation designs is more about getting water to your crops. Water management plans are more what we're interested in this evening. Water storage, licensing issues, trying to figure out how much water is coming into the farm, how much you're using, and how to integrate those. Assessment and engineering is next level. Like if you're going into dams, if you're looking at anything that actually requires engineering, now you're talking about technical designs. You're not getting 100% cost share anymore. It's dropping to 80 or 50%, but you're talking about large figures of money. All of these are funded. You need to get an environmental farm plan first to get into the BMP program. Not the very similar, but for a larger scale project, AWI, Agriculture Water Infrastructure, I believe, program. Anyway, money is out there to do these things. For the projects this year, they were offering 75% cost shares up to $200,000. A lot of money, a lot of people scrambling after that money. Funding disappeared in about 30 minutes. We'll see who actually gets funded in about 8 weeks. Other resources that are out there, BC's put out a ton of resources on farm practices, water storage farm practices, dugouts, storages, flows. You will access it through a web page that looks like this. You can see that there's a lot of different water issues, all of them back-ended with a pile of resources. Some of the first that you should definitely go to are the BC Agriculture Water Calculator, where you can find your address. And my approach is I always stick in 1 acre. I leave it on the defaults, which tends to be a forage crop. You can change this to your crop if you want, but I leave it at forage because it's a good reference of water requirements. They've got various values here. This is peak evapotranspiration. This is a key value we'll look at a little bit. This is how much water a reference crop, usually a grass, is going to use on a very hot, dry day. So in this case, in Cranbrook, 7 millimeters a day. And an estimate of annual water demand. All of this stuff right there. Now, I will put a caveat on this. This is a tool designed for the government to help decide how much water to give people for licensing. It is not really intended as a tool for you to plan your irrigation and water management. It can be helpful and it gives you an idea, but I'll show later how my values sometimes don't jive with what you get off of BC Ag Water Calculator. It's worth triangulating. Another one along the same idea here is a lot of information on your soils through the BC Soil Information Finder tool. Don't stop at BC. Alberta's got a ton of good resources. All the provinces do. Great stuff out there from Alberta on dugouts and dams. Now the regulations vary province to province, so I mean, worth being aware of, but great information out there. We'll take a look at this intake. I just found this the other day. I love this intake diagram, so we're going to look at it again a little bit. The US, by the way, I don't have any US resources up. They also have great stuff, USDA. Less and less great stuff all the time. It's just flying off the web as anything with climate gets scrubbed. Anything that's trying to save the earth is pretty much against the law these days in the US. So unfortunately, we are losing a lot of excellent climate change resources. Not the case in BC, all still available online. BC Climate Change Adaptation Tools and Resources Library still out there with a lot of stuff from the now past, but resources still up, Climate Change Adaptation Program. Lots of good stuff. And if you dig deeply enough, you'll find that my fact sheets that I did a couple years ago are up there. There's 5 fact sheets. Each has, a few pages that look kind of like this, that try and get to the point about what is the most important thing you need to know about irrigation efficiency, and a number of case studies. I'm going to go through them because I do think that this is crucial to your water storage. It goes back to that question about what about, running it through drip lines? Well, you want to know about your pipe diameter and what kind of flows you get through a pipe. And these are maximum flows. There's still a lot of friction loss at these flows. You often want to oversize your pipes. You want to get air out of your pipes. You want to know about the shape of your pipes. There's a lot to know about your pipes and pumps. Similarly, how does the water get out? Is it even? Is it uneven? How do you get the pressures and the nozzles right? Is the water reaching the crop? How can you test that? Using buckets and cups and simple methods to determine if you're getting the right amount of water to your crop. Is the water getting in the soil or is it running off? How deeply is it absorbing? How much water can your soil store? All of these are going to be answered. We're going to look at a little bit more detail in this in a little bit. Suffice it to say, one of the most important things you can do for water storage on your farm is build your soil. So we're talking about green covers to shade the soil, mulches to help reduce evaporation, and also to build the soil. That organic matter is going to make your soil more complex. The more microscopically complex your soil, the more that there is life in your soil, microorganisms, the more water it will store. The coarser your soil, the less it's going to store. It's going to run right through and drain. Compact soils will often have difficulty getting wet. So a lot to think about in terms of your soil and how much water there can be. Planning. When in the season are you going to need your water? This is going to be very important to determining how much water storage you need. So scheduling becomes important. Concepts like how much crop evapotranspiration is there? How much water is your crop actually using? And how much effective rainfall has there been? In our Southeast BC area during the irrigation season, there's usually very little effective rainfall. But on the coast, this is an important number to keep in mind. And the difference between them is how much water you're losing. That's the moisture deficit. That's what we need to replace with our irrigation. The case studies, some of them are hay, one's hay, one's vegetable, and two are orchards. This is on the Thomas Ranch. It's going to put it into perspective. Like, how does this come in? And I like this Thomas Ranch example for discussions of water storage because there's multiple sources of water. It's coming from different creeks and it's getting used in different ways. Here's a pivot, there's another pivot. Here's some wheel lines that are getting moved and then some reel guns. Each of these has completely different irrigation considerations. So it's a really excellent example. The reservoir that was in the bottom left there is actually currently quite small, and it's held back by a small dam. And the question is, can we fix the dam and make a much bigger reservoir? A true, with just a little bit of extra water height, it stores literally 20 times more water. So this is more of a water storage question. Should you raise the height of the dam? Well, it's already a dam. It definitely would require expensive irrigation assessments, and we'll look at some of those numbers later. Is it worth it? You probably want to calculate it out. I often calculate things out in terms of the dollars per cubic meter. So we'll look at dollars per cubic meter a little bit. How much is it going to cost you to store that much water? Is it worth it? This is what it would look like with the water up to that high water mark. So I'm just going to leave you on that picture as we move into water storage now. So these are the topics that we are now going to cover. I've kind of gone through the intro. I've really harped on irrigation efficiency. Now let's actually talk about whole farm planning. That's looking at watershed, precipitation, soil, seasonal sources and seasonal demands. And then we'll move into the question of dams and dugouts, liners, using clay, using Gley. Some people pronounce it Gley, but Gley. Costs, look at all that. And then we'll end up talking about ecology a little bit and water quality. So the whole farm plan, here's another farm in the East Kootenay that I think is another excellent example, because they have multiple sources, but the sources, this is classic for our region, the sources, despite them being licensed, are drying up in peak season. And if you've got a creek and you've got a license on it, it doesn't matter. As soon as there's less water than is needed to keep the fish alive and to keep the aquatic system healthy, the environmental flow need, as soon as you're below that, you shouldn't be drawing anymore, with or without a government stop order on your license. So what do you do? Well, in this case, the question is where can we build or extend storages? And all of these are built as dugouts, dugout meaning entirely below grade. And this goes to that question of moving water back and forth. So there's a number of pumps here to move water back and forth between these storages. And not all of these storages need to be built to store enough water for this farm. So each of these is in a sense an option to run these three pivots for the entire year, filling them up when water is available during spring freshet, when in a sense there's excess water and it's flooding, and then holding off and not drawing from the creek later in the season. I'm going to move back to soil. This is straight out of those fact sheets. Just a plug, everybody should really know what their soil is. And when I'm talking about soil, I'm not talking about the top 6 inches that you send off for a fertility test. I'm talking about going deeper and looking at the soil texture, the layers and the soil texture of each of those layers. And one of the easiest ways you can do this is with a hand feel test. Got a video out there on how to do these. It's very simple. Everybody can do it. And just a squirt bottle of water and something to dig a hole, whether it's an auger or a shovel or a backhoe. Get down there and know what your soil actually is, because you can use that BC Soil Information Finder tool to find your soil survey, and we'll look at one shortly here. But those are often wrong. Those are broad scale tools. They will get you close. They'll give you an idea of what you've got, but they are not what you actually have. Soil can change quite a lot in a very short range in your farm. So you will want to actually dig holes and know what kind of soil you have. It's very critical to your irrigation planning and your water storage planning as a result. Those textures are going to affect water storage. And I mentioned that already, so I'm going to move on from this slide. But the idea here is when you irrigate and you irrigate too much, water will leach out below the root zone. When water stops leaching and it just sort of holds there by gravity, that's called field capacity. And this is sort of the maximum amount of water that the soil can reasonably store. If you are overwatering and it's leaching all the time, you're probably killing your crops. So this field capacity is fantastic. Everybody, all the plants love field capacity. It's a mix of air and water in there. And the plants will slowly use that water. Wilting point is when plants are not physically capable of drawing water out of the soil anymore. There may still will be a lot of water, but it's not plant available. Those are very critical concepts. When we look at this, the tale of two soils, we got a sandy loam at the bottom. This is very typical soil in the Kootenays, and then here we go, the Creston silty loam that we all wish we had. A lovely soil. What is going on in these two different soils? What's going on in these things? Let's imagine the same climate, the same peak evapotranspiration. And in the Creston soil, we're looking at a lot of silt and not so much sand and a little bit of clay. And no rocks. That's really critical. No rocks. And so as you go down, it's much the same. It's this very smooth soil, and it holds a lot of water, a lot of which is plant available. And so you can get 12 to 14 days of water storage on a 100-centimeter rooted plant. Now, the same 100-centimeter deep rooted plant in this sandy loam, well, look, it's a very coarse soil. There's a lot of sand. There's a lot of rock, and you can only get 3 days of storage in peak season. 3 days and your healthy crop will have used up all that water. So really, this is why soil is important, and the soil storage, the best way to fix it or improve it is to get organic matter in there. Okay, on to hydrology. A lot of people build a dugout, they call it a dugout. But is it a dugout or is it a groundwater interceptor? This is very important for legal licensing reasons as well as functional reasons. If you try to line a pond that is intercepting groundwater, it will lift the liner and sort of wreck your expensive pond. I am not an engineer by any means, please get engineers involved if you have any kind of questions about the structural integrity of a built pond. If you are intercepting groundwater, though, the basic answer here is don't. You'll have to build your dugout if you're trying to store water with a liner and end the bottom of the dugout above the water table. So you can, though, use a groundwater intercepting dugout as a water source if it's licensed, as it is in this case. This is a perfectly acceptable way to get water, but it is not really the kind of dugout we're talking about. Also, we got to think about the watershed. This is where all of our water is coming from. And this is where it's important to think like a beaver. That's why I've really stuck a beaver here. And to think about our landscape as a whole, as a province. Plants and plant cover are absolutely essential to our watersheds. Those roots hold the soil together and they slow the water down, the water that is soaked into the soil. The roots hold the soil and the roots together hold that water back. When we chop down our trees, that soil disappears, we lose that sponge. When we cut roads, that is another erosive factor, and it also often directs water out. It runs off more quickly. When we make landscape changes, like breaking beaver dams or taking off natural storages, draining wetlands, we reduce the sponge in the landscape. And what ends up happening is that the water flushes through the system really quickly in the spring when the snow melts, and then there's very little available in the summer. So the idea here that I'm really trying to get across is that if you do own a large amount of watershed that drains into your property and you're able to do something on that, it's worthwhile. It is worthwhile to ensure that you've got good cover. Or get some beavers flown in and don't tell anybody I said to do it. Beavers are our friends here. I want to take a little moment here, though, to really stress the importance of ecology in water accumulation. I love this story about Ascension Island. Some people hate the story of Ascension Island, and because it's so controversial, it's probably why I enjoy it so much. So this little island in the middle of the Atlantic Ocean, close to the equator, and Charles Darwin turned up there in 1836 and found it entirely destitute of trees, in fact, mostly destitute of plants. Very interesting endemic plants and creatures there, most of which are still there. But he saw it differently, and his friend Joseph Hooker, the botanist, came along in 1843, and they just saw this as an opportunity to bring in every plant from equatorial British Empire and plant it. And they used the British Army and Navy, to plant this island, and it continued, and it completely changed how this island functions climatically. It started catching rain. More rain literally came to the island. To this day, water started running, soils started building, and it's now a vibrant, if completely human-made ecosystem, jungle ecosystem. Of course, other people look at it differently. They call it an unmanaged mess of invasive species. I'll let people come up with their own conclusions. I think it's a success. There's rain, there's water, there's biomass, there's biodiversity, there's soil building, there's everything that you would want to make something grow more and bigger. It's certainly a good idea for a farm, if not for a tropical island. So back to our system. Here we have deforestation leading to soil loss. We're losing the armor, we're losing shade in the spring, which leads to faster snow loss. It all leads to water loss. We need to increase the sponges in our soil. I'm going to move on from this, but it is a really critical part of water storage, is really slowing down, spreading out, and sinking that water into our soils and into our landscapes. Now let's look at the climatic trends. This is again from the Cranbrook area, but it's indicative of what's happening in the province as a whole, especially in the interior. That there is generally a lot of variation year to year on how much precipitation there is. So what we have here is the total annual precipitation in green. This is the trend line. The dots are each year, going from 1939 right up to 2024. The pale blue is the summer, and the darker blue is winter. This is in snow equivalent water. You can see that in general, the snowpack seems to have been decreasing. The summer trend seems about on average, and the overall trend is down. Are these trends or not? I think it's really hard to say. We will see. I leave this to the climate scientists. The point is, though, that we are told by people who study the climate that we are not to expect linear trends. We are to expect hockey sticks. Things are going to change quickly, and we might well be at a hockey stick moment in the next decade here, where snowpacks could dramatically decrease. So we want to be prepared for these ideas, for these things. Also, water is going to come in bigger events. There's going to be a lot more water very quickly, and that's all the more reason to have storages that are going to catch that water and slow down that water through the system, so we don't end up with big washouts knocking out bridges and this kind of thing, filling up culverts. Snow also, you can see here is the maximum between 1972 and 2024, going on an average season, January, February, March, all the way to December here. So that snowpack builds up through the season and reaches a maximum usually in April. The minimum here in light blue. So we are, very, very, very large range between the maximum and minimum, from 200 millimeters of water equivalent up to 700 millimeters of water. Now, these thin lines are the last 4 years. Now, I didn't actually update. This is from 2024. This was from last March. It turned into a low snowpack year. This year is a little better. I think we're closer to the average, but we certainly, in a long time here, it's been a while. It's been a while since it was well over average. Got to watch those snowpacks. Evapotranspiration, this is how much actually gets used by plant. This is reference evapotranspiration. This means that we are looking at a plant that is like a 12-inch grass that's very healthy, growing vigorously. It will use less in April. This is April going to October. This is week by week by week on the little dotted lines. We've got in the thin lines, this is actual annual trends, 2021, 2022, and 2023. Jumping all over the map, but this average is in the dark blue, and we got a green showing a trend. So in general, it goes up and goes down. Now, your crop is probably not a 12-inch grass that's just the perfect reference grass. How do you adjust that for your crop? Before I move in, evaporation. This reference evapotranspiration is actually also a really good estimate for how much evaporation there will be. So in April, expect about, in this case, 2 millimeters of water to evaporate a day. And in peak season, 6 to 7 millimeters per day. So this evapotranspiration, which you can get online, farmwest.com. In fact, I forgot to put that in the links. I'll put that in resources when I send out an email. In terms of crops, though, take this hay crop. I like hay because it's a little bit, it's quite visual and we can understand it well. But this applies to any crop. When it is young and just growing up, like it's just not young because it's perennial, but when it's just starting to grow and it's not fully covering the soil yet, it will use less water. This is the hay down here, the average in green, compared to the reference here in blue. But as that crop becomes more mature, the mature hay crop, when it's getting starting to flower, is going to be using more water than the reference crop. But then you take a cut, and when you cut that hay, again you reduce how much water you need. This is a good water conservation technique. You can cut your hay crop. Then as the crop grows, it goes back up again, has a higher water demand, and again in peak season its water demand will exceed that of, when it's mature, it will exceed that of the reference. Then you cut it again, and then let's say you bring in it grows again, and then you bring in some grazing animals and it drops again. So a crop is adjusted according to the size and maturity of the crop and the health of the crop. I also want to point out that I use going from principles on a crop to determine how much water I expect a crop will use in the season. Here I expected it to use 2,300 cubic meters per acre. But when I take the BC Agriculture water calculator, it shows me 2,000 cubic meters. And this is actually fairly typical. I tend to estimate higher than the BC Ag water calculator. I would recommend on your farm, if you're able to use a flow meter or a water meter and actually measure how much water you are actually using in a season. And this is a good way to learn season to season how much water you actually need. This is all theory. Theory's nice, can help us make a plan, but the reality is more important. Another really nice tool to have is soil moisture sensors. Moving right along to a farm example though. This is a 12-acre cherry farm, and I really like this farm as an example because they have 3 water sources, none of which is sufficient on its own to serve the cherry crop that it's growing. So you can see there's young cherry trees here. If we're looking at this map, this is a proposed dugout. This is the XXL version. This is on 3 acres. This is a 3-acre chunk at the bottom of the property, right down here in the picture. And they don't necessarily need the 3 acres. This is to show the largest possible. And we're going to go through a few different variations here to show what the options are. They would like to plant cherries or garlic on the remaining land here, and they would like to irrigate it all. So let's make that happen. Where is the water coming from? Well, there's this creek. A creek runs right here that they pick up at X naught. So here, this creek, they will not be able to pull during the summer. It's oversubscribed. It can't sustain summer pull. But it's possible that they could get licensed to get water off of it from spring freshet. So that's one option for a water source. Down here is another creek on which the farm is already licensed. And here they're licensed for 6,100 cubic meters per year. But that's only enough, even with drip irrigation on a cherry crop, to maybe get 4 acres of cherries, and they have a total of more than that. They also have a drilled well here that when the license comes through is good for 12 GPM. And 12 GPM is great, except if you're just using it in real time, like 12 GPM to irrigate your crop, you can really only get 2 to 3 acres of cherries with 12 GPM, 12 gallons per minute, sorry. So this flow is not sufficient on its own, but I'm going to show in the next slide. I believe it's the next slide. Oh no, it's the one after. We'll get there. First, we'll get back to the water sources. So we got a well and 2 creeks. Demand. So here we have cherries and garlic in a cover crop, and this is the demand. And we've got the demand curve the same way as we showed previously with the hay. So we know this is how much water we will use in a typical season. Now, how are we going to get that water is the question. So now we can go to the slide I was looking for. Here's just using the well. So let's say we weren't using the creeks at all, but what we're doing is pumping that well all year round. So this here is the well getting pumped at 12 GPM all year round, filling up this pond, from which irrigation happens just here in the summer months. So this is a year. So as that well is pumping into the pond is filling up with water until irrigation season starts. And then irrigation season starts and they start drawing off of the storage and pulling off that storage until the end of the irrigation season when they can start filling it up again. So, well, running year round, it's an option, and it can be done with a pond that holds about 13,000 cubic meters. And that covers about an acre. So you'd need about 1.5 acres of land. So that's about half of this XXL dugout right there. So chop that in half and you can do it all with your well. That's an option. Let's look at another option. Oh, we have accounted for evaporation if you're looking at all the bits. We've accounted for evaporation as well. Here we are drawing just off the creek. So here we're pulling off this creek only in the spring freshet. So this is 55 gallons per minute for 3 months. You could squeeze that up. You could make it 100 GPM for 6 weeks. And it's going into this pond, and then that's it. Then you're cut off and you've only got this water to use for the season. So again, then the water storage diminishes through the rest of the season as you use it up for irrigation. So that's another option. What's wrong with this option? Well, if you have to store up front, you have to store a lot more water. There's more evaporation, and you have to have it all ready before the season. You can't be adding as the season goes on. So this pond is literally twice the volume. It takes an acre and a half of pond, not quite the XXL, but we're looking at 2.5 acres certainly of coverage. Big chunk of land. Here we go on the on what I call the XYZ combo pack. Coming up here, we got 6,000 cubic meters coming up from this. We've got some freshet water coming from here, and just 4 GPM from the pump. Let's say the well couldn't produce as much. So here we have 4 GPM coming from the pump. We've got a big chunk coming from the spring freshet, and we're pulling our 6,000 cubic meters over the season coming from the creek down here. That again comes into the storage and gets used during the season. And now we're down to about 17,000 cubic meters of water required. So an acre and a half, 1.2 acres of pond. Okay, we can come back to examples later, but hopefully that sort of puts in perspective how we look at needs and availability of water. Dams versus dugouts. The short answer, as I said, is go for a dugout. That means everything is below grade. If you do a dam, a lot of regulations come into effect, and it depends on the dam height and it depends on the dam volume. So here we have a graph, dam height. This is straight out of the government regulatory information, and here is the storage capacity. If you have less than 10,000 cubic meters, you are a minor dam and you're exempt from most regulations. It's not exempt from regulations, a bit of a misnomer there. There are still regulations. And you can have a dam wall up to 7.5 meters. 7.5 meters off the lowest point of the bottom of the dam to the top of the dam. That sounds great. Well, look over here. This is a minor dam that I recently visited, also in the East Kootenay. That is less than 10,000 cubic meters, but it is above a road and a railway. And therefore, it suddenly is not a low consequence dam anymore. They have to obey all kinds of regulations in terms of dam assessments and then following through on dam assessments. So they're looking at $50,000 plus on just assessments and $50,000 on remediation, $100,000 on a 5,000 cubic meter pond. What's the remediation cost here? We're looking at $20 a cubic meter. So that's the cost of water. You got to ask yourself, do I have other sources? What do they cost? If I don't have any water, what is this worth in terms of my crop? What's the payback in terms of spending that money to ensure I have a legal storage of water? And then of course there's ongoing costs, because once you have a dam, those assessments are actually a regular routine. But of course, once you go through the first set, the other ones are easier and you should just be a maintenance, but it is an ongoing cost and an ongoing hassle. Something else I really want to point out is turkey nest dams. This is not a dugout. So this is actually from Steve Kenyon. It's a great way to make a little livestock pond very quickly and easily. Great ideas from Steve. But I use this as an example to show when you are digging a dugout and you're like, oh, what do I do with all my cut soil here? Oh, I'll just pack it up here and guess what? I can raise the whole water level. Well, that packed soil up there is now just a very poorly constructed earth dam. You have raised the water level above grade. It is in fact a dam. It is not a dugout anymore. So you have to be very careful when you're doing a dugout that it is indeed a dugout staying below natural grade. Intakes, you want to think of your intake before you build the dam. This is why I'm back to this nice little drawing from Alberta. I like this. This is great. It's a good way to do an intake, to float, go into a screen, go into a flexible polyethylene pipe that then goes underground to essentially a short piece of well that has a well pump in it that goes through your pitless adapter, and this is well below frost line, and so your pipe goes off. That's year-round water. Very well planned. there's plenty of other ways to do an intake too, depending on what you need. I want to talk about some water quality issues. One thing they've got here is a 1/2-inch line coming from an air compressor going to an air diffuser so that they're bubbling. Aeration of your pond is one of the best ways to keep your water algae free and to keep it clean. And also, if you're stocking it with fish, the number of fish you can stock is directly related, proportional to the dissolved oxygen content in the water. So aeration can be good for that too. Depth of water, the deeper you can make your dugout, that will also improve water quality. There's something that's missing from this diagram, and that's what this is here, and that's wetland plants on the edge. Those will also increase your water quality and quality of life. We'll talk about that in a little bit. Evaporation, another thing to consider, is one of the reasons to go deeper for a set volume is it reduces your surface area. You can, of course, also get covers over your dugouts to reduce evaporation if evaporation is crucial or if you can't get a very deep pond. Alberta also has an excellent volume calculator. This is if you're just making a trapezoidal pond like this with a set rise over run and a width by a length like a swimming pool, use this calculator. How do you choose these slopes? The slope is going to be dependent a lot on what kind of wall you have. If you've got a liner, you can make it a lot steeper. As you get into other kinds of, like if it's a soil, you're gonna maybe want to be only 2-to-1 or 3-to-1. If you're using Gley, which we'll talk about in a little second here, you need to go shallower still. And 4-to-1 is very standard on biodiversity ponds, ponds where you want to have kids running in and out without necessarily sliding down and drowning. It's good for wetland plants because it gives you a long, shallow area. So some ponds have a long, shallow area and then drop deeper with a liner. Now, how do you measure volume if you don't have a trapezoidal pond? Like this is a place I've been working on. You calculate volumes by taking slices, and you just add up the slices and calculate the volume that way. So this is where maybe having a planner can help you determine how much volume you're going to be able to get in natural dugouts and natural depressions in your land that have odd shapes. What is this going to cost? Okay, this is the big one, because ultimately this is what's going to make or break your project, is if it makes sense financially and economically for your farm. Using, excavation costs can vary by a factor of 10 or more, depending on difficulty. How hard is it to dig the soil? How far does that soil have to move? How big is the project? The bigger the project, the bigger the machine that can come in, and bigger machines can move more dirt. So there you go. These are costs per yards. Costs per yard could go from $3 up to $27, possibly more, to move a single yard of soil out. Now we're going to move back to cubic meters. Sorry for the constant switch between, it's the nature of being Canadian, I suppose, to be bilingual that way, between imperial and metric. But I like cubic meters a lot for water calculations because that's what your license is in, and it's a very convenient measure. So here, these are different pond acreages and a rough estimate of the kind of water volume you might store. In fact, the 1-acre and 10-acre pond, you could increase this storage considerably by digging even deeper. As you go deeper, of course, your excavation costs will go up though. So it's going to be case by case. But for 1/10 of an acre, you can store 500 cubic meters, and that's going to cost you $40 per cubic meter. It's $5,000 in excavation and $15,000 in a geosynthetic liner, so a $20,000 pond. If you tried to scale that up, you're looking at $100,000 per acre. Now that it may not look linear, but we'll show you in the next example again. 1/4 acre pond, again, you're looking at a much lower cost per cubic meter, and the cost per cubic meter goes down again as your pond gets bigger. The amount of stored volume, it's not a linear increase, it's cubic. So we really see a decrease in the size, in the cost per cubic meter as you go down. Then you kind of stabilize around past an acre. So $6 to $8 per cubic meter total, of which roughly half might be excavation and half is the cost of lining and labor. Let's look more closely at those. And we're going to use this lovely pond built by these lovely people in the Slocan Valley, a 3,200 square foot pond with a 3-to-1 slope. And they chose to use clay. So we'll see later how you can use clay and just add it to the soil and mix it in. And then they covered that with road crush. And it's a very functional pond. Ryan here is an engineer and took a very engineering approach to it and did just a great job. The costs here on the side, they were about $6,000 in materials, $4,000 in delivery. So that's a big one. And about $4,000 in labor, adding up to about $14,000 on the pond. If you expanded that to a 1-acre pond, you're looking at $180,000 for a 1-acre pond. So there's other ways of costing out this very same pond. That's what we're going to do now. Just quickly go through different types of liner and what they might have cost on this 3,200 square foot pond and what they might have cost on a 1-acre pond. So let's start with poly liner. This is one that's well known to a lot of people. You cover it with plastic. Now to do this properly, you probably also want geotextile, which is more like a fuzzy fiber, above and below, sandwiching that plastic, so it's really going to last long term. Otherwise you could get punctures and tears. So and you're going to have to weigh that down, so usually you do that with a backfill with maybe a foot minimum really of soil on top to really protect that. Here in this picture you can see the geotextile going down over the plastic and they're raking soil on top. This will mostly be done with machine. Now what does that cost? It's expensive. That material is about $12,000. Delivery is going to be the same whether it's 1 acre or 3,000. It's 3 trucks because they're coming. This actually might be a mistake here. This we could probably get down to 3,000. So maybe take off 6,000 off that. That's an error right here. We'll fix that for the next round. But 20,000 at least for this pond. And it scales up, this is correct, on the per acre. It is a $9,000 delivery cost. Scales up to $240,000 for a 1-acre pond. This is beyond most people. This is expensive. And there are some improved methods now, if you can do them. Now, clay. Adding bentonite clay. If you got a rocky soil, 5 pounds per square foot, down to a silty soil, like if you were doing this in Creston, 3 pounds per square foot is likely sufficient. You pour out the clay, you spread it around evenly, you till it in, and you compact it, and then you cover it up. After you've done that all, you cover it up with soil again, or in Ryan's case, you cover it up with road crush. What does that cost? It's a lot cheaper. And now this is the backfill. Doing it with road crush costs more because you got to buy the road crush. It's got to be delivered. So here, just backfilling with subsoil is usually sufficient in most cases. And so I've added a backfilling component here in the labor section. And so it's about even, $4,000 in each. Maybe it's a $12,000 pond, 11, 12,000. Scales up to 150,000 on a 1-acre pond. Here's a new layer, a new liner, geosynthetics. Geotextile is clay layered inside, like a sandwich of geotextile with clay in between it. And now this is, really becoming very popular. It's big Chinese developments have been using these, and increasingly new developments in Canada are also using this. It seems like a very good product. When Ryan looked at it, it was too expensive, but I have recently been working with another farm that found it for a lot cheaper out of Alberta. So let's look at those costs. Here we go with about the same as doing it with clay. So, and it's got some advantages over clay. It could be an easier install. It could be something that can go with steeper walls if you want more depth and a steeper wall. Also, the delivery cost goes right down because you only need 1 layer, and it also reduces the labor cost. So it really starts paying off big on the big scale. Now we're down to about $105,000, $110,000 for an acre. Okay, we got one more. So this is the old permaculture side of me coming out, coming home to roost. But I would like to see somebody try this on a small scale. I'd like to see this done, and it's probably going to be me in the backyard, but that's not quite the same as maybe even a bigger scale. This could be worth doing. It could be especially worth doing if you have livestock and you feed them hay. What are we talking about here? We're talking about a 3 to 4 inch layer of wet green stuff. So imagine hay, packed hay. So here I've been calculating on 6 inches of really, really hard packed hay that you've wetted down and is really soaked. And then you cover it up with 4 inches, or I've calculated in here 6 inches of compacted earth. And then you let it sit and ferment. So you do this in the summer and you get a good ferment going on under there. You're making a slimy pickle. And then you fill it up with water, and that's your layer. Now you cannot do it at a very steep slope. So this is the drawback. It has to be a 3 or 4 to 1 slope. Otherwise the Gley might slide off the slope. But the advantage is you can do this with hay, and you could do it feeding animals. So what I figured is if you took large square bales, you know, one of those ones are about 3 by 4 by 7 feet, like you see in this picture here. This is my neighbors down the hill doing a great job bale grazing through the winter. Tighten up these bales to about 20 feet in all directions from other bales and get the cows in there on that. And they will eat that hay. They'll fill it with manure, which is actually even better. It's much better, like manure mixed with greens and fresh sappy materials. That makes an even better ferment. You know, get them to eat through that whole thing. And then at the end of the summer or whatever, you cover it all up with your soil and tamp it down, compact it. After getting good and wet first, then the soil. And now we're talking about a fermented compost. What's that going to cost? Well, let's say you bought perfectly good feed quality hay. So that's as expensive as you can go. You can probably find at half price somebody's waste hay that got rained on, or it's 2 years old or whatever. You can probably find some old hay much cheaper. But here, just for sake of argument, $300 a ton hay. You need 11 tons to do a 3,200 square foot pond. But that's, you know, 3,000 bucks a hay. And maybe you need 3 people in a tractor for 20 hours to spread it all out. And then you need a little bit of time to do some backfill on that. We're looking at a $6,000 pond for that 3,200 square foot pond. Scale it up to an acre and you're well under 100,000. And again, if you're doing this as part of a livestock feeding operation, you might even be seeing much lower costs per acre. So that's a good segue going from the eco approach to pond lining to get into riparian restoration. You don't want your pond to look like this. This has clearly been pugged from lots of cattle coming in to feed off the side. There is no riparian vegetation really outside of weedy grasses. This is just begging for some plants, and it will improve the water quality. It will shade the pond, and it will prevent the wind from blowing. It should reduce evaporation. When you first build the pond is the time to do restoration, and it's when it looks like heck. You can't do, this is a wetland restoration, not a storage, but I mean, you cannot do wetland restoration or pond work and not have it look a little bit like a bomb went off. One of the best ways and least expensive ways to do this is with live stakes. You can harvest these when the leaves are down, cut those stakes, soak them or stick them straight in the ground if the ground's wet enough. And what happens is if it's willows or dogwoods or cottonwoods, but mostly willows and dogwoods, they will root right off of those nodes and turn into a bush. They will quickly stabilize a slope, and live stakes are used. This is just a few of the many, 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 many kinds of bioremediation using live stakes that can be done to secure a slope and to get riparian stuff growing. These are some live stakes that we put around our pond. This was the year that it got built. Nothing was growing. The next year in the spring, we threw in live stakes, and this is 3 years later, 4 years later, it's growing into bushes. I mean, really, it's just harvest some sticks and stick them in the ground. You can get money to do this though. So back to the BMP funding, you can get money to get a professional to give you a plan. You will need that plan to get the money, and then use that plan to get 60% cost share up to $70,000 to do restoration on your pond or to plant up your dugout or the creeks leading into it. Natural swimming pools. I like this idea a lot because it really combines using technology and human ingenuity with the wondrous powers of microorganisms and plants and insects. What you have here is a circulation system that, instead of using a pool pump and chlorine, is using air in a tube. So here's a tube blowing out air bubbles. The air blower is right here, and as those bubbles come up, it pulls water through this substrate where the wetland plants are growing at the side of the pool. So again, here's your swimming pool, and here's your substrate, and the plants are growing out of it. So water gets pulled through those plant roots in through the substrate and then gets bubbled out. So you got this circulation system right here cleaning the water. This is pulled directly and without permission. Very sorry, David Pagan Butler, but hopefully people will go to your website now and buy your book, How to Build a Natural Swimming Pool. And you too can make something that looks like this if you're trying to get into better homes and gardens, or you can just use a very simple farm approach to the same method that doesn't have to use expensive landscaping to make it look so beautiful, and make your farm pond much cleaner and much more natural. And I will speak from experience here that it doesn't take long after you build a pond, if you put in riparian plants, for the frogs to move in, for the dragonflies to move in. And these are your key allies. The mosquitoes on our farm have decreased, not increased, with water storage. So I just want to nip that question in the bud right there. But you too could do something beautiful. Do put a sauna beside your pool and take a swim. And that's all I have for the presentation. So we can go right into questions. Nigel.
Thanks, Andrew, for doing this. It's a lot of information. All right, here's a quick question. So when is it a problem? When are there extra regulations or requirements if you have a seasonal creek that would flow into the place where you want your pond and then flow out again?
Yeah, that's a big one. You need to talk to Walrus ahead of time for sure about this situation, because if you do not have rights, I'm going to assume you don't have water rights on that creek for irrigation.
No, but it's also like, when is a creek also? Um,
when when it is known about and it is above ground, and actually a creek is a creek in the regulations, even if it runs ephemerally, like if it runs only for a part of the year, it is also a creek. Any water that runs onto your property from off your property is the province's water. And really, let me reverse that. The only water that is unlicensed is water that falls within the boundaries of your farm, like your owned property, and essentially stays at the surface, which maybe like rainwater harvesting is your water. You don't need a license for that water. Water that falls right into your dugout is your water. Falls onto the driveway and runs into your dugout, your water. If it soaks into your soil and enters the aquifer, no longer your water. If it melted off of your neighbors and flows over the surface into your property, no longer your water. So that water, that creek is the province's water. And when it goes into your dugout location, it makes it not such a good dugout location in a sense, in that that will definitely introduce new regulations. And you will need to talk to somebody about your specific context. And people at the water branch are going to be very happy to talk about it. But especially if you're looking to get funding, everything's going to have to be above board from the beginning. So my best advice would be to make allies with the folks at Walrus and see what is possible. The best option for a dugout is to make it somewhere where the water isn't.
Mm-hmm. One takeaway for me, tell me if I'm wrong, looking at some of the calculations about water needs and water storage. If I was to try, for example, to replace all of the water I use with stored water, the pond I would need would probably be bigger than my farm. Like it
Not
to have to
necessarily.
store a really significant amount of money, you are looking at a fairly large.
You are looking at a large pond. But for example, like in that cherry farm, which is in your neck of the woods, actually, so very similar water demand, and orchard demands are higher than your vegetables, most likely. There, we're looking at a 1 acre storage, essentially, 1 to 1.5 acre storage to irrigate 12 acres. So it's a one
Mhm.
to 10 ratio there.
Right.
So
Well,
if you're irrigating, I forget how many acres of vegetables are we trying to irrigate here, Nigel?
1.5.
1.5.
Mhm.
So you are talking about a smaller pond.
Yeah, are there requirements for a pond to be fundable on the size of it? Like how significant that water storage could be to my actual usage, or any requirements about that? Is it okay to have uh, a pond that's basically just a kind of emergency backup storage that would get me through a few days? Um, is that still something that's fundable?
Absolutely, absolutely. And in your case, with a relatively secure water source, that's what you're looking for is a sense in a backup plan to hold you through 2 weeks where a water main blows or something. Am I just
Yeah.
you can justify water storage for many different reasons. I don't know if they're using wildfire protection as a justification for water storage. I will have to look at that, but certainly any irrigation purpose, as long as you're licensed to irrigate, can be fundable, and it doesn't matter on the size. What will be impacted by the size, as I said, is that there's this cost of a smaller pond. It's going to cost more per cubic meter. It's going to cost more per surface area because you're doing a smaller pond. You're going to have to do all that work for a relatively smaller amount of stored water. But whether it's small or big doesn't affect how it can be funded, at least not yet. I haven't seen any indication of that.
Okay.
But that is an interesting point, like having water just for a backup. Uh, that is a perfectly good reason to have a water storage. Any kind of water storage is a good idea. Really, one of the ways that we want to protect ourselves from climate change and is to have redundancy in our systems, and particularly our water systems. If you're reliant on a single source of water, that already sounds like a great reason to consider at least storage to back yourself up for a week or a month.
For a lot of the funding, there is a requirement to either have an irrigation system assessment or a water management plan done in advance. And I was wondering if you could just maybe explain a little bit the difference between those two and when you would recommend each.
Yeah, they serve different purposes. So the irrigation plan and the water plan is what we're comparing here. The irrigation plan is really to design the nuts and bolts of the irrigation system and make sure it matches not just the water license for one. It has to fit within the water license, and then it has to match the crop. It should be the most efficient system. And the system is something that then gets designed in conjunction with the farmer, because the most efficient system includes, in my mind, a large labor component. Really, often guns, for example, get maligned as an inefficient system. They can be managed very well, I think. If a gun is properly set up on the right lane spacing with the right nozzle at the right pressure, it can be very efficient and can be the most efficient if you've got long, narrow fields. And it's certainly more efficient in terms of labor than a wheel move, where for a typical large gun can cover 3 times the area in one pull as 3 wheel moves. So we go through all of these questions in an irrigation design. What are the options? Do you want drip here, or do you want micro sprinklers? And what's the difference between them, and which would you prefer? All of these come with costs and benefits, and the irrigation design works through them and ends up with a design that you can take to a supplier, or it could be made by a supplier. A lot of these designs are done by suppliers. and you can get the parts and put in your system. So irrigation design is fairly straightforward in that sense, and you can use it to get funding. A water management plan is quite a bit different. It is looking at how much water does your farm need at different times of year, what are the climate impacts likely to be, what's the precipitation in your area, taking a closer look at the scheduling, when water is needed at different times of year, what is the licensing situation on the farm, are there potential water sources that the farm should maybe consider applying for a water license on? Is a dam the best idea here? I mean, I know I stomped on dams, but maybe a dam is the best idea. A water management plan will help identify that by looking at broadly the availability of land and the costs associated and how much water would get stored and how and where that water would get used. So those are two different plans, and often I will do both at the same time because they do impact each other a lot. If you want a good water management plan, it's best to have a good irrigation design to begin with. On the other hand, sometimes the availability of water will affect what kind of irrigation you can design. Went all over the map there. Did that answer the question, Sarah?
Yeah, I think one follow-up, you mentioned that a supplier might be able to do the irrigation design for you. Would that satisfy the BMP requirement for an irrigation system assessment, or does that need to be, it needs to be a certified designer, but if they had one, basically would folks have to pay for that? Or could they maybe get their supplier to pay for the plan so that they could fast track to getting the infrastructure application in when it opens?
Well, I mean, yeah, let me put it this way. There is money available to get an irrigation design. And I would highly recommend getting that irrigation design well in advance of funding, which in the past came around every April and this year came around in February. So plan in advance. Now until the fall is the best time to be getting in touch with your environmental farm plan advisor and talking about what plans you need to be ready for funding the following year. Plan in advance. I really can't stress that enough. What does end up happening a lot is that people suddenly think, oh, you know, I want to get funding and it's November or December, and they'll call me up or they'll call up suppliers. And we want to please, we want to help. Suppliers especially are motivated because they know they'll probably get a sale out of it. But it's very difficult in that, partly being in the winter, it's difficult to visit the place and actually do the assessment. And it crams up a whole lot of plans all at the last minute. So I really would say plan in advance. Yes, you can certainly get your irrigation supplier to do it. If you're going to get an irrigation supplier to do the plan, I would say you're not beholden to buying from them, but I would say that ethically, morally, I would say you should probably be also planning to buy from them unless you're paying for that plan. So many suppliers may, out of the goodness of their heart, do the plan for you. It's more than they have to do for a quote. Normally, suppliers will just give you a quote and they'll give you the system. The plan is more than just a quote. A plan has mapping, it has assessment of the efficiencies, and there's various elements that have to go into that plan. Sure, some suppliers may, out of the goodness of their heart, do that for you on the hope of getting a sale, but I would recommend going through the environmental farm plan, getting a paid for design, doing it in advance, getting a nice design and being ready for the next year.
Yeah, I mean, Andrew, you've been out to my place. And I guess the thing is, it's like when we've done excavation around the property and kind of looked around, in the spring, we do get like a pretty big flush of like a high water table. And I'm talking, 2 feet below ground is it's like there's the water table. And then obviously, as you kind of get into August, September, that water table recedes down 8-9 feet down or so, or even further in some cases. I guess the thing is, it's like, given kind of what you're saying about a linered pool, getting pushed up or something with a high water table situation, or the inverse of that being like, we've got really high drainage soils to not use a liner, then it's like, oh, I guess like dugouts aren't for me, question mark. I don't know where it's coming from necessarily is sort of the answer. Is it's like it has nothing to do with the river. It might have something to do with snowpack melt locally, or if there's some sort of like old underwater flow of 49 Creek that kind of flows out towards our bench versus like where it cuts down, like the creek itself cuts down and like boots it straight into the Kootenay Canal. But
Totally. Thanks, Scott. I just pulled up your place and now I'm back on track. I honestly can't say where that water is coming from, but what we can say for sure is that you have observed that water level going up and down. So you do know that you've got groundwater coming in and out. And that's probably enough. What people might do in that situation is put in drainage. So you could cut above your dugout and put in drain tile and drop that groundwater around to some kind of lower storage, perhaps even for that groundwater. Now, if you're actually accessing water that's in the aquifer, I'm going to just mention, because there are folks probably from the government online, or they're going to see this later. Once you are accessing water that is in an aquifer, so is groundwater, you are now accessing water that does need to be licensed. And I know you're familiar with that too. So as soon as you're putting in that drain tile, you sure could use that water if it were licensed. But that is one way that if you need a dugout in a certain area and you need it lined, you can divert the groundwater the same way as you would around a basement.
All right, for Michelina, I'm wanting to build a series of connected ponds for irrigation using drip lines. Gravity-fed irrigation would be amazing if possible. My farm is on a slope, and I'm thinking of using a solar-powered pump to move water from the lowest pond to the highest pond. So not specifically a question, but I suppose is this a possible, how is this going to go sort of question?
Yeah. Okay, so a series of connected ponds using small lines with gravity irrigation and a solar pump to move the water back up. Yeah, all of this is all possible. Most of what you can dream up is possible. Now, I spend a lot of time working on designs where we work on that kind of setup. The thing that jumps out on me is like feeding them with drip lines. The issue comes down to pipe sizes. And so that's where I was going to segue into a lot of these irrigation resources. You got to think about flows and pipe sizes, friction losses. There's a lot of hydrology that goes on in pumping water and moving it around in pipes. And it is really helpful to have somebody who knows how to work those numbers to make sure your system will actually work. Otherwise, you'll end up faking it over and over and over until you figure out the hard way through trial and error. You can calculate this stuff ahead of time. Yeah, one more question since we're on questions.
Perfect. And I guess just maybe to tack on to that, you're talking about the math behind both the pipe sizes, the pump sizes, all those sorts of details.
Yeah, and we are going to go through that this evening.
Fantastic. All right. And then just a last comment, would love to learn how to know if you need a liner or not, which I'm sure you are going to get into.
Yeah, so well, I mean, very briefly, if you live in the Kootenays, unless you're in a crest and silt loam soil with a pile of clay, and even then, that's only 15% clay down there. You got to do it very carefully. Usually, anytime you're below 20% clay, you're looking at a liner of some kind. And we're going to go through liners in some depth. If you do have a really fine, beautiful soil with lots of clay, one way that you can amend just by adding some clay in the top layer. And in that situation specifically, that could be the cheapest option. But we're going to get through all the costs there and look at liners.
Terracont noted that the BC water calculator that Andrew showed does also have a dugout feature.
And that will be, that is good. I would recommend playing around in the BC Ag water calculator. It gives some interesting, I didn't mention it, but there's a show monthly amounts button that's fun to push, and it'll give you estimates on how much monthly amount is required. Again, grain of salt on that, because that is all based on estimates. The climate models behind it Sometimes I disagree with what the peak evapotranspiration is based on new data that's coming out. A great example of that that's worth keeping in mind, since I see people from Creston on the call and also from Grand Forks, those weather stations did not go in until very recently. There was one weather station in Creston, but now there are 6, and we're getting much better data. In Grand Forks, the weather stations that we're using there are quite recent. And so therefore the models that are behind the BC Ag Water Calculator have not been updated to this new data, which tends to suggest actually more water requirement than has been assumed in the past. So use the BC Ag Water Calculator. Andy Nadler and Stephanie Tam have put together a new website with all of the agricultural weather stations. It's much easier to use than Farm West was. All that information is available. That is the place to go now. I will send a link to that place, and I can't remember what that place is called right now. My apologies.
Tara's put it in the chat, bcagriweather.ca. Thank you, Tara.
Thank you. Beauty. That's what it is. BC Agri Weather. Really great site. Kudos to those guys for pulling it off. They've been working on that for some time, and it's really worthwhile. Well, I want to thank everybody for coming out and listening to me go on and on for a long time there. Definitely, it's a topic close to my heart. Happy to talk to anybody about this. Again, Kootenay and Boundary Farm Advisors, we're here to answer the phone, so please do be in touch. If you don't have an environmental farm plan, I'd recommend getting one. It's your foot in the door to funding at the very least. It's also a way to get to know an advisor, get to know the regulations. And if you're in our area, it's likely to be Sarah or Rachel or myself at the moment. And other than that, have a wonderful evening. I look forward to hearing from you all in the future, and best of luck with your water in 2025. May it be a bountiful season.